Friction. Friction. To understand friction, let us consider the following figures. Left upper figure indicates a block moving on another block by applying a force capital F. By applying a force capital F, the upper block moves over the lower block. But the motion of the upper block is prevented by, it is opposed by a force acting to the left. This force is known as frictional force. See the bottom figure. If a spherical body is pushed with a force F to the right, then at the point of contact it experiences a force to the left. This is frictional force. Suppose, see the right hand top figure. If you roll a body in the anti-clockwise direction, then at the point of contact a force acts to the left. In the middle figure, you notice a body rotated in a clockwise direction. When the body is rotated in the clockwise direction, a force acts to the right at the point of contact. This is frictional force. If the spherical body is pushed to the left by applying a force capital F, then a force small f will be produced at the point of contact to the right. This is how a frictional force acts. Let us try to understand why this frictional force and how this frictional force acts. Definition. Friction may be defined as the self-adjusting force which comes into play tangentially between two surfaces so as to destroy the relative motion between them. Friction may be defined as the self-adjusting force which comes into play tangentially between two surfaces so as to destroy the relative motion between them. The direction of action of frictional force. The frictional force acts along the surfaces in contact and always opposite to the direction of motion of the point of contact. It always acts opposite to the direction of motion of point of contact. Suppose if you take rolling friction. Here in the upper figure, if the spherical body it rolls in the anti-clockwise direction, then the point of contact of that body, spherical body, moves to the right. Hence, the frictional force acts to the left. Take the bottom figure. Here, the body moves to the right. It is a sliding. It slides to the right. When it slides to the right, the point of contact moves to the right. Hence, the frictional force acts to the left. If the body rolls in the clockwise direction, spherical body rolls in the clockwise direction, the point of contact moves to the left. It tries to move to the left. So the frictional force acts to the right. Cause of friction. Friction is due to the interlocking of the surfaces. When we consider two objects in contact, the surfaces are generally uneven, rough surfaces. That means there will be elevations and depressions in the surface. Even if a surface appears to be smooth, under microscopic conditions we notice elevations and depressions. See the figure. Uneven surfaces. The uneven surfaces, projections and depressions of one surface get interlocked in another surface. The projection of one surface falls into depression of another surface. Hence, the projections and depressions get interlocked. When the upper surface is dragged to the right, then the interlockings should be broken in order that the upper block may move over the lower one. To move the upper one over the lower block, we have to break the interlocking surfaces, interlocking elevations and depressions. Hence, to break these surfaces, uneven surfaces, we need to apply some force. So we experience a force in the opposite direction, as though preventing the motion of the blocks. This force will be opposite to the applied force. This is the frictional force. The opposition to the motion due to the interlockings is manifested as the frictional force. This arises due to the roughness of the surfaces. Types of friction. Types of friction. Friction is of three types: static friction, dynamic or kinetic friction, and rolling friction. The friction that acts on static bodies. When one block is at rest on another block, to move the upper block we have to apply force. Capital F represents the applied force. As the applied force increases, it is opposed by a frictional force. So this force is known as static frictional force. Before the upper block moves, the frictional force that is experienced is known as static frictional force. Once the block B comes to the kinetic state, moving state, then also a frictional force is experienced. That frictional force is kinetic frictional force. So the frictional force on moving bodies is kinetic frictional force or sliding frictional force or dynamic frictional force. In the case of spherical bodies or cylindrical bodies, then the bodies will roll on a surface. During the rolling also, the bodies experience frictional force. The frictional force experienced by rolling bodies is known as rolling frictional force. So, friction is of three types: static friction, kinetic friction, and rolling friction. In the figure, capital F is applied force and small f is the frictional force. Types of frictional forces. There are three types of frictional forces: static frictional force, dynamic or kinetic frictional force, and rolling frictional force. The frictional force on static bodies is called static frictional force. Frictional force on static bodies is static frictional force. Frictional force on sliding bodies is dynamic or kinetic frictional force. Frictional force on sliding bodies is dynamic or kinetic frictional force. Frictional force on rolling bodies is rolling frictional force. On rolling bodies, it is rolling frictional force.